Here's another example of finding domain for composite functions, and this one's got radicals in it. So if I have f of x is 3x minus 2 and g of x is the square root of x plus 4, can I find, first of all, f of g and then its domain? Okay, well, f of g, first figure out what g of x is, the square root of x plus 4, and then we're going to do f of that. So we're going to take this and plug it in up here and get 3 times that square root minus 2. That's our composite function. Okay, now what about the domain? 2 steps. First, where did x go? It went into g. All right, so step 1 is figure out what restrictions do we have to have for just the g function. Well, I've got the square root of an x plus 4, and we know that what's underneath here has to be greater than or equal to 0. In other words, x is going to have to be greater than or equal to negative 4. The second step is look at this composite function that we just found. Say, are there any additional restrictions when we look at the final result? No, we still have the same radical, so we're going to get the same restrictions. Our domain for the composite f of g is the square root, negative 4 inclusive to positive infinity. What if we reverse it? Okay, what if we do g of f of x? Well, this time x is first going to go into f, and we're going to get the 3x minus 2. Okay, and then we're going to do g of that. So we're going to take this 3x minus 2, and we're going to replace this x in the radical by 3x minus 2 and then add 4. If you simplify that, you get 3x, square root of 3x plus 2. That's the composite function. All right, so the 2 steps again. Where did x originally go? It went into f. Well, that was that linear 3x minus 2. There were no restrictions. My domain could be anything. So then the second step is, okay, look at my final results. And what restrictions would you have there? Well, this time I have a 3x plus 2 underneath the square root, and I need that to be greater than or equal to 0. If you subtract and divide, you recognize that x has to be greater than or equal to negative 2/3. Okay, so no restrictions, and then this one. So when we think about both of those together, we get the domain of g of f is from negative 2/3 inclusive to infinity.